Hi, fourth grade. Soils, Rocks, and Landforms, Investigation 1, Part 3, Chemical Weathering. So what is physical weathering? Let's go ahead and review that from our last investigation. We've seen that rocks break into smaller rocks when they bang and tumble against each other or when ice expands and breaks them apart. That's what we call physical weathering. But there are other ways that rocks can be weathered. Sometimes substances in the air dissolve in rain, creating a weak acid. Substances get into the air from natural sources like volcanoes and from human-produced sources such as car exhaust and factories. Let's find out how acid rain affects earth materials. So our next focus question, and I would like you to write this down on a lined piece of paper, please, or in your notebook. How are rocks affected by acid rain? So after the investigation, you will be answering that question. And the investigation is 2 parts this week. So write this down and remember that's what you're going to be answering as we go through the investigation. How are rocks affected by acid rain? For the first part of the procedure, here are the materials and the actual steps to the procedure. So there'll be a phos tray, 4 labeled self-stick notes, limestone sample, a sandstone sample, a marble sample, and a basalt sample. So I have written the name of one of the rocks on both sides of a self-stick note, and I placed it in one of the tray compartments. I placed a rock sample on top of each label, and you will first have a chance to observe the rocks that you see. Draw and describe your samples on the notebook sheet as I inform you to do. I do want you to take a picture of your observations and put them on Seesaw or by email. For this part of the investigation, we are going to make some rock observations. I would like you to set up your paper so that it looks like this. Write rock observations at the top. Divide your sheet into 4 sections. 1, 2, 3, 4. Write basalt, capital B-A-S-A-L-T, limestone, capital L-I-M-E-S-T-O-N-E, marble, capital M-A-R-B-L-E, and sandstone, capital S-A-N-D-S-T-O-N-E. This is where you'll write your observations of the rocks that I'm about to show you. Please make sure you take a picture of it and send it in to me either on Seesaw or email. So let's go ahead and take a look at the rocks. Please, as you're observing, notice colors, shapes, if you think it looks rough, whatever you notice about the rock. So we're going to look at basalt first. You can see I have it labeled. So I'm turning it around. What colors? I mean, it's not super rough, but it does have some, sharper edges. It's not super smooth, but it's not super rough either. So that's basalt. Write down your observations, please. Next is limestone. You look at my fingers when I touch the limestone. Okay, what colors? What do you notice? Limestone. Then we'll go with marble. What colors? When I touch it, notice what happens. And last but not least, sandstone. I'll tell you, it's a little bit rough. You can see the colors. There's more than one color. Make sure you list them all if there's more than one. So that's sandstone. So please write down your observations on that notebook page and submit them either on Seesaw or on email. Thank you. For the second part of the procedure, there will be the 4 vials, 1 syringe, 1 cup of vinegar. So I will put each rock sample in a vial next to its labeled spot. I will place the 4 vials into the corner sockets of the tray. I will carefully put 25 milliliters of vinegar into each vial using a syringe. For the next part of the investigation, I would like you to set up a notebook sheet so it looks like this. Rocks in acid rain, observations of rocks in vinegar. So I want you to list basalt, and then next to it will be where you write your observations. Limestone, observations, marble, and sandstone. I left about 4 lines between. If you want to leave more, you can. So when you're writing observations, what do you see happening with the vinegar? What do you see happening with the rock? You see different colors, any observation that you might see. Okay, for this part of the investigation, we're going to use white vinegar to model acid rain. So I'm going to put each rock sample into a vial next to its name. So the basalt's going into the vial next to basalt, limestone, sandstone, and marble. So I'm going to carefully put 25 milliliters of vinegar into each vial using a syringe. I like to go a little bit more so then you could squeeze it out. Get to 25. So put it into basalt. Putting it into the limestone. Into the sandstone. I'm going to do that again. If you do that, it's okay. You can do it again. Had a lot of air in there. And into the marble. So now, I want you to look at each one, see if you see anything happening. Ooh, what do you notice about this one? Wonder what that is. This is the limestone. Sandstone. Ooh, did you see that? And marble. So after I place the vinegar into the vials that contain each rock. I want you to really observe the vials to see what happened. And on the notebook sheet, I want you to record your observations for each of the rock samples. What did you notice happening inside of the vial? So as you were making your observations, I bet you noticed some bubbles. So what do bubbles indicate? Bubbles indicate a chemical reaction. A chemical reaction is a process in which two or more materials mix in a way that forms new materials. In this case, the limestone reacted with the acid rain and created a gas. Continuous streaming of lots of bubbles is evidence that a gas is being produced as a result of a chemical reaction. Sometimes it's hard to tell if there are the right kind of bubbles. A few bubbles may suggest an air pocket in the rock. We have another test that might provide additional evidence to indicate if a chemical reaction occurs. We are going to let the vials rest overnight and then check them for more clues.